So I had to restart the recording. I know this stuff's not easy, so I'm glad people are asking questions. I know, especially in this virtual world, and we're not face-to-face, you know, it's not easy. So that's why I like to, you know, that's why I'm glad people are asking questions like this. So good. All right. Any other questions? And again, I mean, I know theoretically you should be able to get the graph or at least approximate it. So, well, no, excuse me. You should be able to get the range from the graph, you know, by drawing these lines. But with the quadratic function, as I was saying, you don't have to, which is nice. So, okay, so the next example, actually, let me turn the recording off, because the next example, I want everyone to try on their own. What the, oh, jeez. This one. I was going to have everyone try it out. In fact, I was going to have everyone try out a few of these. So, you know, give it a shot for like a few minutes. Okay. Then we'll just go through it together. So let me turn off the recording. Okay. So let's do this one together. Again, if you didn't finish, that's okay. I just want everyone to, you know, try working on these. Okay. So for this one, right? Here, what do we have? We have A is equal to 1, it looks like. Okay, as you can see, you know, again, if the coefficient is not there, then it's understood to be 1. So A is 1 in this case. B, we can see is -3. C, we can see also is 2. Okay. Okay, so let's get the vertex. What would the x coordinate be? Well, again, it's -b over 2 times a. Okay, -b over 2 times a, which is also in this case -3 over 2 times 1, right? A is 1, b is -3. So in this case, we would get 3/2. Now, personally, I would just write it as a decimal. I mean, you could leave it as a fraction if you want, but don't forget, you have to evaluate the y, you have to find the y coordinate by plugging it into the function. I mean, you could just use a calculator also if you want. So, okay. All right. So we have that. So again, for the y, so this is the x coordinate of the vertex. For the y coordinate, we have to evaluate this. We have to evaluate, excuse me, the function at this. So we have f of 1.5. That's 1.5 squared minus 3 times 1.5 plus 2, which turns out to be -0.25. Okay, so we have our x coordinate, we have our y coordinate. So the vertex, excuse me, is going to have coordinates 1.5, -0.25. So that's the vertex of this. And also the axis of symmetry is x equals 1.5. Okay. Now, what about the y-intercept? Well, that's what f of 0 is, which turns out in this case to just be 2. Now, notice the A is positive, right? So in this case, the range is going to go from the y coordinate of the vertex, right, to infinity. And we include the y coordinate, that is, we put a square bracket around it, next to it, I mean. And infinity, we never put a square bracket next to it, so we have this open parentheses. And again, this is since A is positive. On an exam or something, I'll tell you what to find. I mean, in the past, I haven't told people to find the axis of symmetry, so for instance, but I'll tell you what to find now. So we have all this information. Okay, so that's good. We can actually, well, let's get the x-intercepts. You know, actually, yeah, let me do this. That's what I've done in the past. You can actually make a rough sketch of the graph already. You know it's going to open upward, right? Like so, where the vertex will be at the very bottom here. you know that the axis of symmetry is, which is the vertical line that goes through the vertex. But hopefully you can see from here, the vertex is down here, why the range has to be this. You know, the range is going to go from the y coordinate up to infinity. So, all right. But to get a better graph, we really need the x-intercepts. So that's what I'm finding here. Notice here I'm actually factoring it. You could use the quadratic formula if you wanted to. You know, either one. You know, I'll tell you what method to use if I want you to use a certain method. Otherwise, you can use any method you want. So here we have this thing, and we're going to factor it. Well, notice this is a trinomial. The leading coefficient is 1, right? So, excuse me. So what we want then is two numbers. It's also degree 2. That's also important. So we want two numbers whose product is 2 and whose sum is -3. So off the top of your head, you should be thinking, oh, -1 and -2. And that's what I use the factor here. Right? This would be our -2. This would be our -1. So, okay. So instead of having this equal to 0, we would have this whole product equal to 0. And remember, when you do that, you set each factor equal to 0, right? So the first factor is x minus 2. That's equal to 0. The second factor is x minus 1. That's also 0. Now, how do we get x? Well, here we just solve for x. So we can add 2 to both sides. You get x equals 2. So 2 is an x-intercept. Here we have this one, x minus 1 is 0, right? So we can add 1 to both sides. We get x equals 1. So this tells us that 1 and 2 are the two solutions to this equation. Hence, they're the two x-intercepts. So now we can sketch the graph. Namely, we get this. Okay, let me just draw the arrows. The indicator keeps on going. Okay. All right. So again, you can see that, yeah, it crosses the x-axis at 1, well, at the point 1, 0, and 2, 0. That's why 1 and 2 are the x-intercepts. Here's the vertex, right? The axis of symmetry, let me see if I could draw it. I mean, I guess you could draw it as a solid line instead of a dashed line.